Last time we looked at the rise of BE Incorporated and how their BeOS operating system almost became the future of the Macintosh. But once the Apple deal fell through, BeOS eventually found a new home on Intel PCs. So today we're going hands-on with BeOS on the x86 platform. Under the dust, there's history waiting to boot. I'm the Vintage Collector and these are my stories. Yeah, I know, you probably like to see BeOS on a Mac as well. But remember, I don't have a beige Power Mac, so we'll have to stick with Intel for now. And if you missed last week's episode, be sure to check it out for a historical overview of BE Incorporated and the early days of BeOS, and why the system never supported the later New World Macs. Coming from there, it was inevitable that BE would look for a new target platform, as there was no future in PowerPC Macintoshes and Mac clones. The first Intel version of BeOS then appeared with Release 3 in March 1998. Not long after, BE also secured new funding from Intel, which took a 10% equity stake in the company. At the same time, Hitachi announced that it would bundle BeOS 3.0 with some of its Pentium 2-based Flora Prius desktop PCs, marking BE's first major OEM partnership. I found a copy of BeOS 3.0 on Winwell PC. You may be surprised to find that there are 2 ISO files in the archive. However, only the small one is an actual ISO 9660 file system. The second file is, despite the .iso filename extension, not an ISO 9660 file system at all, but actually contains a BFS formatted file system. Now, on the original CDs, these 2 images were mastered as multi-session tracks, with the ISO 9660 session being visible and the BFS section hidden behind. The split into 2 distinct images is beneficial when installing in VirtualBox. But as we're going to see, I had some obscure issues with that anyway, so we'll explore a more advanced capability for handling native disk images in 86box later on. For now, in VirtualBox I was mounting the small ISO file, which dropped me right away into an installer. To simplify setting up BeOS on existing Windows systems, BE included a custom version of Partition Magic, which had no other job than helping to resize the existing partitions to make room for BeOS. Once I had done that, I mounted the floppy image and also swapped the small ISO for the larger one. This brought up the BeOS bootloader and the installer, which unfortunately failed to recognize the partition layout created by Partition Magic and repeatedly locked up. So I gave up here and switched over to 86box instead. And that seems to do it this time around, bringing up BeOS 3.0. Looking around it, it comes with the usual suspects of control panels and bundled applications, even a bunch of demos like the GL Teapot, which I promise you we'll see later on over and over again. BE eventually released an update to BeOS 3.1, which could be seamlessly installed in place. And it's the same experience for the BeOS 3.2 update as well. The only thing I noted was that BeOS wasn't able to shut down or reboot the system on its own, even though the emulated system supports advanced power management. I then tried to go straight into BeOS 4.0. But that's where the problem started. Remember what I said earlier about those multi-session CD images I had for BeOS 3.0. It turns out the images I got for both BeOS 4.0 and 4.5 were not directly usable. Probably good for restoring the actual CDs for installation on a real PC, given you burn them in disk at once mode, but not good enough for using inside the emulation. Obscure errors like this one, not finding a shell, are indicative of 86 box failing to properly access the multi-session structure. Luckily, I eventually found a different image which also came with the .q file. This is where 86 box offers a magic trick, as you can also point it at the .q file, which then just tells it the multi-session image structure. That made it work so I could install BeOS 4.0 over BeOS 3.2. And one thing I noticed here was that the GLT pod offered a better frame rate. So some optimizations to BeOS were obviously applied to improve graphics performance, and they even become noticeable inside the emulation. Once I upgraded to BeOS 5, it even got better. And finally, the automatic reboot and shutdown works correctly. Now, BeOS was always promoted as the real-time media OS, but is somewhat hard to demo inside an emulated computer. You can literally hear this stutter in the background. So we should eventually look at this on real systems. But let's look quickly at an interesting fact. Even though BeOS offers a terminal and actually is using Bash as a shell, the OS is neither Unix nor a Unix derivative. It does, however, provide some POSIX compatibility, and in fact many popular Unix and Linux applications have been ported to BeOS. By 1999, estimates suggest BeOS was running on somewhere between 50 and 100,000 machines. When Release 5 introduced the free personal edition, downloads reportedly exceeded 1 million. And maybe I'm just falling for the Mandela effect, but I seem to remember that for a period of time, the BeOS personal edition was on literally every computer magazine CD back in the year 2000. Now, the personal edition was only a subset of the full version. Only about 45 MB in size when compressed, BeOS PE came with a Windows installer which placed a 512 MB image file onto your hard drive, no repartitioning required. The image file, comparable to a virtual hard drive as widely used in emulation and virtualization contexts, contained a B file system, or BFS for short. BFS was a modern 64-bit journaling file system developed specifically for BeOS in 1996. But what really made it unusual was how it handled metadata. Files could carry arbitrary attributes, and those attributes could be indexed. Once indexed, the file system could perform live queries against those attributes, meaning the file system itself behaved a bit like a database rather than a simple hierarchy of folders. And if that concept sounds familiar, Microsoft later attempted something similar with WinFS, a planned database-style file system for Windows. Interestingly, the main developer of BFS, Dominic Giampaolo, later joined Apple in 2002. At Apple, he first implemented journaling for the HFS Plus file system and later helped initiate the Spotlight search system introduced in macOS X Tiger. Spotlight works differently from BFS, using a separate indexing service rather than file system attributes, but the core idea is very similar: fast metadata indexing and instant search. So in a way, the concept that BeOS pioneered in the mid-90s eventually reappeared in the Mac world as Spotlight. Once installed and unpacked, you can launch the BeOS Personal Edition right from the Windows Start menu. Technically, what happens is that Windows exits into MS-DOS mode and launches the BeOS load command, which starts the kernel. It uses similar techniques such as loadlen to load the Linux kernel from DOS. From there, it looks almost exactly like the BeOS professional version, except that on my machine it initially came up in monochrome mode and the wrong screen resolution. Booting again and pressing the spacebar as soon as the loader appears gives you access to the boot options, where you can change the display settings. And there we go, now it's running at 800 by 600 in 60-bit color. And here's once more the GLT pod producing a frame rate roughly comparable to what we saw earlier in 86box. Since this version of BeOS literally bootstraps from DOS, you can also unpack the image file manually onto a DOS machine and start it from there. That's exactly what I'm doing here on this 1994 high-screen Intel PC with an original Pentium 60 running MS-DOS 6. Unfortunately, the graphics hardware in this system is clearly too old, only providing a basic grayscale support, and this system wasn't really usable anyway because it failed to recognize my serial mouse. Anyway, BeOS Personal Edition was released to capture momentum. It made the system easy enough to try in a non-invasive way, and B saw quite some interest coming from this. However, the reality was that BeOS 5 arrived at a very difficult moment. By 2000, B Inc. was struggling with the same problem that had followed it since the end of the B-Box era: distribution. OEM partnerships had largely failed to materialize, with only a few limited attempts, such as systems from Hitachi shipping with BeOS in Japan. B eventually sued Microsoft, alleging that Microsoft discouraged PC manufacturers from shipping systems that could boot anything other than Windows. At the same time, the broader landscape had changed. For users looking for an alternative to Windows and Mac OS, the growing popularity of Linux offered another path. Be then tried shifting toward internet appliances, refactoring BeOS into a lightweight embedded platform under the name BIA. But these efforts ended almost as quickly as they began. In August 2001, B agreed to sell its asset to Palm Inc. for roughly $11 million. In 2003, the lawsuit against Microsoft ended in a financial settlement worth $23 million. Even with B Inc. quietly dissolving and the BeOS intellectual property moving to Palm, BeOS itself did not completely disappear. While the company did not release BeOS as a whole as open source, parts of the BeOS desktop, namely the tracker and the deskbar, have been open sourced. Meanwhile, in Germany, YellowTab released Zeta in 2004, a controversial BeOS distribution of questionable legal status. Some enthusiasts even created enhanced unofficial builds of the BeOS 5 Personal Edition, distributed as BeOS 5PE Max. And at around the same time, a community project called OpenBeOS began re-implementing the system from scratch, later renaming itself to Haiku. But that, along with some deep dives into BeOS applications, is a story for next time. I'm the Vintage Collector, and this was my story for today. Thanks for watching, and see you again next Sunday.